Hi, my name is Muhammad Nur Badin Smawan. So now I will present about the executive summary for our group project. A truss bridge is one in which the load-bearing superstructure is made up of connected elements that usually form a triangular unit. In reaction to dynamic load, the connecting elements, which are normally straight, may be stressed by tension, compression, or both. The goal of this project is to design and determine the degree of determinacy. Next, analyze the internal force and analyze the reflection of the truss bridge. First, we must get the lecturer approval for our design. Then we assign responsibility to each group members in order to finish this work. We employ a different strategy for calculating and designing this bridge, and to analyze truss deflection and design structure, we employ StatPro software to calculate the acting force on each member and analyze compression, tension, and deflection using other methods. Finally, we learn how to construct bridge and the many types of bridge, and we may also learn from this project that every available design will have an impact on the truss bridge construction. This is all for me. Thank you.
Hi, Assalamualaikum, and a very good morning to our doctor, Dr. Gawan In, and to my fellow friends. My name is Muhammad Sufi Shabir Ahmad Zaidi, CF 200-141. I'm going to discuss about introduction. In theory, a truss bridge contain no redundant members, uh, while most trusses could sustain considerable damage and lose the support of some members without collapsing, severe traffic damage to a member could result in a collapse of the bridge. Bridge that we choose for this project is Union Pacific Railroad Green River Bridge at Kent, Washington. This is the picture of the bridge located at the Kent County, Washington. So the objective is determine the degree of determinacy of the Union Pacific Railroad Green River Bridge, analyze the internal forces of the Truss Union Railroad Green River Bridge, analyze the deflection of the Truss Union Pacific Railroad Green River Bridge. So the reason is my team picked this bridge because this bridge has a long span that can support the train that brings a cargo to their destination. After that, the length of the bridge is 48 meters. Of this bridge is sustainable to use for train because of the trusses and members. The bridge, our bridge is statically determinate, which is we can refer to this picture. The member is 29. The reaction is 3 because of pin and roller, and the joint is 60. Using equation m plus r equal to j, just get 32 equal 32, and it is statically determinate. Thank you.
So I will present about the manual calculation. So this is our truss. First we determine the truss, and our truss is statically determinate. After that we calculate the support reactions. After that we calculate the internal forces. This is an example how we calculate for each joint using method of joints. After that, this is our full internal forces after the calculation. After calculate the internal forces, we do the vertical displacement. So we put 1 kilonewton vertically at joint I, and then we calculate the separations. After that, we calculate the vertical forces for each joint, and this is our vertical forces. So for table of deflection, we fill in with length, internal forces and the forces, and then we multiply them. After that, we will get the total. And after we get the total, we will calculate the deflection. Total of F mu L divided by AE. A is area, E is elasticity, and then our final answer is 18.588 mm. So that's all for manual calculation. Thank you.
Hi, my name is Muhammad Nafi bin Sulaiman. So I will continue our discussion. So as we know, trusses are usually used in bridge, roof, and towers. The design for this project, truss is 6 meters of length, each members, and 8 meters of height. And our design bridge has 29 members, 60 joints, and 3 reactions. And we got statically determinate. Our material of bridge is steel, and the elasticity we got 2005 kilonewton over millimeter square. After we do calculation for the force, we got 18.588 millimeter deflection from theoretical method, but when we use step pro, we got 18.834 millimeter. So it means 1.3% error was identified as a result of comparing theoretical calculation and step pro software. And so the material of our bridge strength and material workability, factor of safety, and others. So that's all our discussion for this project. Thank you.
Assalamualaikum and very good morning to Dr. Goh Wan In. My name is Ahmad Fauzi bin Muhammad Safwan and my metric number is CF200148. And today I will present about conclusion. As a conclusion, in order to obtain a high effect bridge design, it is important to identify the different forces such as compression and tension in structural members. There are several elements that we must consider before we design the truss bridge, which is height, length, and distance between members. It is very important to understand how each member works together as a whole in a structural system. By using manual calculation, it is little bit inaccurate. Meanwhile, by using step pro software, it is more accurate because we get the error between manual and software, which is 1.3%. Okay. And lastly, the joint of two members have to fit to each other as nicely as possible in order to become a stronger bridge. The rationale for this is that the load can be distributed uniformly from one element to another, resulting in a stronger construction, and as a result, a more stable bridge can be produced. That's all from our group. Thank you.